In this video, I'm going to remind you how to do a z-test calculation by hand. And remember, a z-test is the one when you're trying to compare your sample and see how the scores in your smaller sample compared to the larger population that we know a lot about. So for this specific problem, we're going to be thinking about IQ scores. So let's say that we know in the population that the mean IQ score is 100. And remember, this mu is the mean in the population. That's how we denote that. And we know that the population standard deviation IQ score is 15. And that's what this lowercase sigma means. Now let's say that we want to see how the population IQ compares to our sample of kids that we have whose moms had German measles when they were pregnant. And we want to see if having German measles affects people's IQ when they grow up later in life. So I have a smaller sample of these kids that I want to compare to the population. So in my sample, I have 20 kids whose moms had that illness when they were pregnant. And we know that the mean for our sample is an IQ of 97.3. So you can already see it's just a little bit lower than the population mean. But we want to know, is it significantly differently lower than the population mean? And in our sample, we also we don't know what our sample's standard deviation is. So what we're going to do is try to come up with a z-score that kind of puts this sample and compares it to the parameters of the population. So we have everything we need to calculate that. And we're going to go ahead and calculate the z for our sample. So the formula for z when you're doing a z-test for hypothesis testing is the sample mean minus the population mean over the sample standard deviation divided by the square root of your sample n. Now remember, all of this stuff here on the bottom is the standard error, which is important to remember. So let's go ahead and plug in all of our pieces here. We have our x mean, we have our population mean, our population standard deviation, and our n. So we're just going to carry this through. So our sample mean was a 97.3. And it does matter what order you put this in. So make sure you keep it in the right order. So sample mean minus our population mean over sample standard deviation is 15 over the square root of our sample size is 20. And so then you just reduce out from there. And remember to do your order of operations. So you do the inside of the square rooting first. Then you're going to divide this on the bottom. And then you do the whole big fraction altogether. So I'm going to keep reducing. On the top, when you subtract these, you get a negative 2.7. And on the bottom, I have 15 over, and if you do the square root of 20 on your calculator, you should get 4.4721. And I would recommend carrying out at least 3 or 4 decimal places here so you don't make a big rounding error. I'm going to move it back up top over here. So we've got a negative 2.7. Over, if we do this fraction on the bottom, you get 3.354. And then your final z amount is going to be a negative 0.81. So that's your z. And remember, we're not done with our hypothesis testing yet. We have kind of where our sample is relative to all the other scores in the population. And let's remember what that distribution is going to look like. So again, we're assuming that our underlying population of IQs is a normal distribution. So the mean is right here in the middle, and it's a mean of 100. And so where is our z of negative 0.81 going to fall? So you know it's going to be on this side, the lower half of the distribution. And this is negative 1, negative 2, negative 3. It's going to be about right here. That's our z-score. And remember, in z-hypothesis testing, the critical value for your z-test is always plus or minus 1.96. So you'd have to be in this region of rejection right here in order for your sample to be significantly different from the parameters of the population. If our z is right here, it's not in this region of rejection way out here on the tail. And what that tells us is it's not that different given what we would expect for a normal population of IQ scores. If our Z was somewhere out here past a negative 1.96, then we would say we reject the null hypothesis. Since it's not, since it's right in here in the big middle part of the distribution, we say we fail to reject. And remember, when you fail to reject, it's always P greater than 0.05. So we would conclude that just because your mom had German measles when she's pregnant doesn't mean you're necessarily going to have a significantly lower IQ than people in the population. And that's how you calculate a Z-score.